Hello, and welcome to the webinar. My name is Sean Larson. I'm a Strategic Global Alliance Manager with Amazon Web Services. We also have today Sam Bisbee, Chief Security Officer of ThreatStack, and Michael Atkins, Security Analyst of SailPoint. Today, we are going to talk about how to secure your containerized infrastructure on AWS Cloud. Security is a job zero for AWS, and we don't have a business if we can't secure our services. We know it's going to come up eventually. The CISO will find out, and we want to get ahead of it. Prevent anti-patterns from emerging and introduce new ways to improve security as you transition workloads to AWS. Most of all, we bring it up and earn trust of our customers. Your data on AWS represents your business and your livelihood, the trust with your customers, and the privacy and security of real people. For many enterprises, even those several months, or even a couple of years into their moves to the cloud, it's still new territory. If you operated data centers and traditional networks for 40 years, some of this is going to feel new. Customers want to know that they can maintain a sense of control, so we help guide them and chart a new territory. Lastly, security has always been just plain hard, and our customers want to get ahead of it. We look after security of the cloud, and customers look after security in the cloud. AWS responsibility, security of the cloud. AWS is responsible for protecting the infrastructure that runs all services offered in the AWS cloud. This infrastructure is composed of hardware, software, networking, and facilities that run AWS cloud services. Customers' responsibility, security in the cloud. Customers' responsibility will be determined by the AWS cloud services and partner solutions that a customer selects. This determines the amount of configuration work that the customer must perform as a part of the security responsibilities. For a long time, organizations had to make a choice between moving fast or managing a high degree of security. One of the fundamental benefits of the cloud is that it lets you do both. Our infrastructure is architected to be one of the most flexible and secure cloud computing environments available. For startups to big organizations, speed matters a lot. My goal for this session is to show you how to move fast and stay secure at the same time. Many organizations face challenges maintaining and managing the security of their on-premise infrastructure. But why? Lack of visibility. In an on-premise environment, it can be difficult to know what resources and data are out there at any given time, where it is moving, and who is utilizing accessing it. For example, it requires expensive, complex tooling to get accurate, real-time asset inventory. Most organizations just don't have that level of visibility that they would like to on-premise environments. And without visibility, it is challenging for organizations to adequately secure their infrastructure and their data to meet the security and compliance requirements. A low degree of automation. Another typical challenge is trying to get rid of the manual process employed to remediate issues. Think copying and pasting information from one tool to another, or manually applying patches. It's been difficult to automate key security tasks due to issues such as interoperability of third-party and homegrown tools. Manual processes tend to lead to inconsistent execution, longer wait times to address all systems, and in most cases, disrupts the customer experience. So the goal of automation is to programmatically handle tasks that would otherwise be done manually by IT staff. This is much easier in the cloud, as well as we will see. The combination of lack of visibility into their own environment coupled with a low degree of automation compromises the organization's ability to move quickly and effectively secure their on-premise infrastructure. Scale securely and superior visibility and control. With AWS, you control where your data is stored, you access it, and what resources your organization is consuming at any given moment. Fine-grained identity and access controls combined with continuous monitoring for near real-time security information ensures that right resources have the right access at all times whenever your information is stored. Reduce risk as you scale by using our security automation and activity monitoring services to detect suspicious security events like configuration changes across your ecosystem. You can even integrate with our services and partner solutions to support existing workflows, streamline your operations, and simplify compliance reporting. Automating security tasks on AWS enables you to be more secure by reducing human configuration errors and giving your team more time to focus on other work critical to your business. Select a wide variety of deeply integrated solutions that can be combined to automate tasks in novel ways, making it easier to secure your security team to work closely with developer and operations teams to create and deploy code faster and more securely. For example, by employing technologies like ThreatStack's data portability and leveraging AWS machine learning, AWS enables you to automatically and continuously discover, classify, and protect sensitive data in AWS with just a few clicks in the AWS console. Security at AWS is our top priority. That is why we listen closely to our customers to offer both a secure cloud computing environment and innovative security services that satisfy the security and compliance needs of most risk-sensitive organizations. Today, AWS protects millions of active customers around the world. Our customers represent diverse industries with a wide range of use cases, including large enterprises, startups, educational institutions, and government organizations. The scale and global reach of these customers give us a broad visibility and deep perspective of cloud security, knowledge which we rapidly reinvest into our leading edge infrastructure and services. Security at AWS starts with our core infrastructure, custom built for the cloud and designed to meet the most stringent security requirements in the world. Our infrastructure is monitored 24/7 to ensure confidentiality, integrity, and availability of our customers' data. The same world-class security experts who monitor this infrastructure also build and maintain our broad selection of innovative security services, which can help you simplify meeting your own security and regulatory requirements. As an AWS customer, regardless of your size or investment, you inherit the benefits of our experience, tested against the strictest of third-party assurance frameworks. AWS is vigilant about your security. Because our customers care deeply about data security, we have a world-class team of security experts monitoring our systems 24/7 to protect your content. With AWS, you can build the most secure global infrastructure, knowing you always own your data, including the ability to encrypt it, move it, and manage retention. We provide the tools that allows you to easily encrypt your data in transit and at rest to help ensure only authorized users can access it, using keys managed by our AWS key management system or managing your own encryption keys with Cloud HSM using FIPS 120-2 Level 3 validated HSMs. We also give you control and visibility you need to help demonstrate that you can comply with regional and local data privacy laws and regulations. The designs of our global infrastructure allows you to retain complete control over the regions in which your data is physically located and helping you meet residency requirements. AWS supports more security standards and compliance certification than any other offering, including PCI DSS, HIPAA High-Tech, FedRAMP, SEC Rule 17A-4, EU Data Protection Directive, and FISMA, helping satisfy compliance requirements for virtually every regulatory agency around the globe. In addition to security of our environment, AWS makes a wide range of security tools and features available to our customers. Depending on the security of the application or the content you choose to deploy, AWS and its partners offer over 700 tools and features to help you meet your security objectives. These tools mirror the familiar controls you deploy within your on-premise environments. This means that you can deploy a wide range of security controls in your AWS environment without the capital outlay. AWS provides security-specific tools and features across network security, server security, access control, and data security. Also, AWS provides oversight and monitoring tools so that you can detect problems quickly and remediate them before they impact your business. Next, I would like to introduce Sam Bisbee, Chief Security Officer of ThreatStack, and Michael Atkins, Security Analyst of SailPoint.
Thank you very much. That was great. This is Sam Bisbee. I'm the Chief Security Officer here at ThreatStack, and we're going to get started here introducing both ThreatStack and SailPoint and kind of the context that was just laid out for you. So to kind of enter us into that context, to introduce you to ThreatStack, we are the leader in cloud security and compliance for infrastructure and applications, where we help companies securely leverage the business benefits of the cloud, like it's been discussed, with proactive risk identification and real-time threat detection across different cloud workloads. All right, so traditionally our customers are cloud native, think tech companies who were forward thinking and they built their tech stacks on AWS. However, increasingly our customers are shifting all production workloads to the cloud as established players. They'll typically discuss this as digital transformation projects, but generally we're seeing larger and larger enterprises commit real spend into the cloud with companies like AWS. And they're looking for solutions to provide that real-time threat detection and proactive risk identification. So that's where we're able to help them. And the reason why we wanted to pair with SailPoint, one of our longest customers in this webinar, is because SailPoint really embodies both of these personas, where they were an early cloud adopter and ThreatStack adopter, but they've also got hybrid deployments at scale. They ship software, and they're not a company that was born yesterday, right? So they're an established player. So Michael will be able to bring a unique point of view into this conversation. As a matter of housekeeping, I'd also like to high-level the ThreatStack solution as Michael and I talk through SailPoint's usage. If I can get there we go. All right, so logically at ThreatStack, we break our solution up into 3 pieces, and this will provide a kind of sane architecture for you to understand the capabilities that Michael and I are talking through on this webinar. First, where we all need to start, there's the data collection for visibility, right? So this is a combination of agent and agentless technologies. There are many people over the last couple of years who are arguing no to agents and no to agentless, and one's better than the other. There are benefits to having agent deploys, and there are benefits to having agentless deploys for visibility. And so we've actually combined both an agentless and agent technologies to ensure full stack security observability for AWS, regardless whether you're running containers and orchestrators like Kubernetes, your servers are running on EC2 and maybe on-prem for hybrid cloud deployments. But so no matter what you're running or where you're running it, we're that cloud security observability partner, providing full stack observability. The second component is the platform itself, which is delivered in a true SaaS model without the need for virtual appliances or other hidden total cost of ownership, TCO accelerators, right? We never liked the idea of requiring customers to have to scale infrastructure on their own to be able to support what we do. So all of those agents and agentless integrations and everything that we're deploying out in that first stage is delivered completely through a SaaS model. No additional spin up or scaling need on the customer's behalf, so it's truly frictionless. So all of that data, alerts, and findings are available through our open APIs, webhooks, and can even be synced directly to the customer's AWS S3 bucket, right? So one thing that companies are normally very nervous about in a true full SaaS model, especially in the security world where you never know when you're going to need to pull a bunch of data to do digital forensics and incident response, is we allow customers to take all the data that they want out of our platform. We're not holding on to those bits and putting them in kind of this glass fishbowl. Everything can be pulled out through polling our AWS, our APIs. We could push out through webhooks, or we can just sync all data, including pre-alert enhanced telemetry. We can just sync all of that directly to your S3 bucket. So while you're leveraging us as your cloud optimized IDS, you can be running additional ad hoc analytics, correlation, your SIM, whatever you like, over in your own environment. Or as was alluded to, you could pull data out of that S3 bucket into a managed AWS data offering like SageMaker to go experiment with machine learning for your detection and response needs. Speaking of response, the third aspect of what we do is there's an optional code managed service that sits on top of our platform only. So we're not managing your next-gen appliances or anything else or your AWS environment directly, but we sit on top of our own platform and tool. And this is the threat stack SOC looking across our entire customer base for trends, escalating active issues with deep context from our investigation, and performing monthly risk analysis with action plans for proactive risk remediation. We'll see some examples of that in a bit, but a lot of what we're going to be talking through in here around examples of incidents and customers having a bad day, it's all informed off of that threat stack SOC. So this isn't just kind of backroom conversations. These are things that we're actively observing out in the marketplace in customers' production AWS environments. Right? But for now, I'd like to hand off to Michael from the SailPoint security team to discuss their environment and start to introduce you to SailPoint.
Cool. Thanks, Sam. Definitely appreciate that introduction and that context. So SailPoint Technologies is a leader in the identity access management and governance space. And basically, what we do is we treat individual user and account identities as fundamental and central to a holistic security posture. We do that by breaking down identities into their atomic attributes, so their entitlements, privileges, and we analyze those things in the context of their participant groups, roles, and account memberships. And so that gives our customers the ability, we also give our customers the ability to provision and deprovision access as appropriate, and to slice and dice their employees' identity information to meet their security, compliance, and governance goals. This all began with our on-prem product, IIQ. We've extended to SaaS, as Sam alluded, with Identity Now. And we continue to grow that by applying our identity insights to file access management. And we're growing our identity analytic capabilities with machine learning and AI. So that's a little bit about SailPoint in a nutshell. Sam? Okay. So I guess I'll just jump into architecture. So our architecture is we use microservice, and so we use microservices as kind of our key functional deployment model. So our functionality is distributed across a suite of small, independently deployable services. These microservices are targeted with respect to their functionality, and they're powerful engines for processing our Identity Now actions. They're also containerized so that our engineers can develop, deploy, and scale changes independently and quickly. they're really a key component of any market-leading cloud-based product line like Identity Now. And so that kind of serves to frame our functional or product functional features. All of this takes place in an AWS account context. So we're mindful of AWS, the functions we inherit from AWS, so security groups, ACL configs, the host configs, where our images come from, the AWS control plane, IAM, and so on. So so there we're probably much like a lot of the listeners on this podcast, or on this webinar, with respect to the things we have to keep in mind when running in AWS.
Great. So I think given that context on how you're running that environment, it's often useful to level set on how all these environments look as we're trying to establish a holistic detection program. And I think what we can all appreciate on this call is that this can be an especially challenging as we're experiencing rapid replatforming in tech. Maybe one of the fastest replatforming in history between cloud, containers, and all these other things. Containers are relatively recently adopted technology at scale in production, where, I think about it, just 3-4 years ago, very few people really understood or knew about containers, and there were still, kind of religious battles about which version and flavor and technology stack to standardize on. Now there's an entire ecosystem, and it relies on distributed system orchestrators like Kubernetes, whether they be running it yourself or managed by AWS on your behalf, right? Meanwhile, each new piece of tech that we adopt or build on relies on the integrity of the layers below it. So that's this diagram that you're seeing here that we're going to be looking at a couple different cuts on, right? So my application at the top of the stack there relies on the release artifact, which relies on the integrity of the runtime. That entire app tier then relies on the integrity of the container tier, therefore on the host tier, and therefore on the virtualization hardware tier that AWS is absolutely providing to you. And to Sean's earlier point, they're really managing the security on your behalf for, right? So while it's hard to depict, it's also important to remember that your build artifacts play a role here too, right? And so that's the things in yellow, that your release artifact, container spec, call it Docker file in your machine image or AMI. We regularly catch threat actors trying to breach build systems to steal keys for direct prod access. Think if your CI/CD system is pushing these release artifacts directly out to hosts or directly out to a Kubernetes orchestrator, the keys for that on that CI/CD system, those are very valuable, because now if a threat actor steals them, they have authenticated in what looks like normal access into your production environment. But sometimes they're targeting those build systems to inject malware directly into the release artifacts, or to include it into an overall build package or an AMI. Right? And we often joke here at ThreatStack that while CI/CD are powerful accelerators, especially for product velocity, we joke that they are by far the best malware distribution systems that have been built, right? Because they're really that transit hub at the nexus of how value is flowing through your organization between the corporate environment where people are writing code, your pre-production dev test environments, and then that ultimate production environment where hopefully that's the only place that your customer data lives, right? So one of the ways that you can control and limit your exposure and transfer ownership of this risk is adopting AWS managed services because of that shared responsibility model that Sean was discussing earlier, right? So for example, while you can run Kubernetes on EC2 yourself, you'll then own the security of the stack from your app all the way down through the EC2 host OS and that machine image, right? This is a lot for any team to take on, let alone an established company with a large security program and budget. But then you go and you look at an earlier stage company and the security team finds out that Kubernetes is going to production 2 weeks out. This is a conversation that we have customers practically on a monthly basis, where they're being told last minute, hey, we're sending this thing out to production, we're standardizing on containers and Kubernetes, and it's just Linux, right? So all the things that you were telling us to do beforehand, they apply equally. And for those of us who've been running this stuff, we know that that's not the case. And if you're a security professional and you've never run Kubernetes before, you can probably get your gut feel going that that's not going to be the case, right? So depending on your team's experience and comfort in securing the integrity of this whole new stack, you may want to only focus on securing the integrity of your apps and containers, setting policies in AWS managed orchestrators, thereby reducing your deployment security complexity by offloading that host OS and a lot of the managed service ownership to AWS, right? Then you can leverage ThreatStack for the full stack security observability for what you both do and do not run on your own, right? So that's way that you can kind of control this, to say, okay, we're shipping Kubernetes and containers to production in 2 weeks. Let's just at least start with, Amazon ECS with Fargate. So that way we're not trying to also manage the underpinnings of the orchestration in this environment. We can just focus on pods and workloads and containers, those higher level abstractions, because the goal is to manage applications, not infrastructure. Right? And so where this gets really complicated is then we consider the runtime interacting directly with the infrastructure control plane, right? So this is the functional equivalent of your, VM farms admin console, your, big IP appliance admin interface, or the SCADA system, is managing your environmentals in your data center. The functional equivalent of all those management interfaces and APIs being directly on the internet is a way to enable self-service operations remotely, right? We need to remember that these are features and the reasons why we're all adopting public cloud from a vendor like AWS is that they provide such rich and excellent functionality that we can leverage safely. But it does introduce this new interesting paradigm where EC2 instances, the apps and containers that run on top of them are all equivalent of users with physical data center access. The fact that the EC2 metadata API has been sitting at a hard-coded IP address of 169.254.169.254 for all these years is great. And a lot of our tools like the Chef Ojai plugin has been leveraging these features for so long, but they introduce new potential problems, right? So focusing on containers, one thing that we've observed out in the wild multiple times now is, a botnet is scanning through an IP range like normal, finds a remote code execution on the system, executes that, and ends up down at the container level. They didn't realize it was a Kubernetes cluster, but now the malware and botnets are smart enough to detect this. And so we actually saw this in a customer's environment going into Black Friday, where the malware landed and then realized it was targeting Redis and it was inside of a Kubernetes cluster. So it actually used the kubectl admin command to tell the cluster to run a Redis client command across all of the Redis containers in their farm. That's completely legitimate. And, yes, they hadn't locked down their pods and all these policies and everything, but there's a very new ecosystem, and those best practices are hard for teams to operationalize. But it's also hard to remember to pay attention to that, because previously the concept of a workload reconfiguring the orchestrator or reconfiguring infrastructure, that was a very foreign concept. But now it's a very real concept. And we've got additional examples and deeper dive on more sophisticated attacks leveraging these features, including AWS features and functionality. All that's available on threatstack.com for more information. But I think through this lens, let's use this opportunity to dive back into SailPoint's environment. So Michael, if you want to pick it up from here.
All right, thank you. So when we looked at adopting ThreatStack, we had to deal with a variety of the challenges on our side of the shared responsibility line, like you were talking about, Sam. And among those, we had a lot of compliance goals to meet with our auditors and stakeholders. We also had a relatively small team, and scaling that team up is well, one of the benefits we've gotten is kind of a staff augmentation. Because as you said, there are a lot of new, we're operationalizing, we operationalize, I should say, a lot of new and emerging best practices to help us monitor and detect various threats in our environment. And we also wanted our security program to be supportive of the goals, or the goals of our dev team and of DevOps. So those are kind of how we've gotten to where we are. So, and the way we've operationalized ThreatStack is we've used it as a early warning system to give us alerts about things that go on in the environment, and those things feed our incident response workflow, both in terms of alerts that come through the console and with our managed relationship, and that helps. That's also informed how we've structured our security incident response procedures, or they've fed it, I should say, fed our incident response procedures, and helped us really improve our posture in this space.
Great. So let's go through a couple of escalations now that we've kind of reviewed this. So here for the audience, these are a couple of example alerts from a mock environment or from our demo environment. So we're going to be running, Michael and I are going to be running through some kind of high level on kind of what got fired and why, escalation, and then talking through kind of from the SailPoint perspective on how they think about and manage these types of incidents. These aren't specific to a containerized environment, but they could easily be happening inside of a containerized environment, since so many of the remote attack TTPs mirror for both, whether it's an EC2 Linux host only or whether there's containers running on top of it as well. So we're going to start out with user privilege escalation above here, which got fired from a syscall from an example host. So this is something that a SOC analyst would take in, and they would see that this is not typical for a kind of mock hypothetical SailPoint environment, because we know that they're managing their environment with configuration management, and that's something like a SHD config file that would be managed by the config management. We saw that default user was used, and that's definitely not typical access for their environment. They're at identity governance shop, and they're definitely not leveraging default users like this. But then we also see when the analyst searches back across when people do log in, when they are in this environment, what are they doing? We see that no one has ever used a nano text editor before, right? It's typically always Vim, Emacs, something like that. So we pull all this information, some additional information, like what else is happening in the session, and we escalate with this context to the SailPoint team. And we typically recommend isolating the host and anywhere else these keys are being leveraged, right, on this box for the whole infrastructure. So Michael, kind of given that, when you get an escalation from ThreatStack like this, what are your first steps? Are you manually re-verifying and handling the incident? Are you going in, pulling us onto a call? Kind of talk through your initial steps and how you would see something like this.
Well, initially the alert would come in. We would have an analyst look at it, especially since it's something that would fall outside our process. There we would leverage, I guess you could say we'd be leveraging the behavioral analysis we've gotten from ThreatStack in that alert. We'd look carefully at some of the things you highlighted, like the user that did it. Again, the tools, I think, noticing, the types of applications that they're using to execute those commands is obviously adds a good deal of context and insight. We would also go back into the ThreatStack dashboard to see what surrounding events may have contributed to what got us to this place in the first place. And then once we've determined that, we'd obviously take some sort of action if action hadn't been taken by the time we got the alert from you guys in the first place. And then we use it to inform everything from subsequent actions to after action reviews and policy modifications.
Great. I'd like to stay with that after action kind of post-mortem. Let's say it turns out to be a legitimate operator access. So we went in, we found out, yep, this is some sort of more break glass edge case event. How do you and your team think about using alerts like this at SailPoint? Would this kind of be ignored in a backlog queue or in a post-mortem incident report? Would you follow up with the user directly to try and coach them? Or maybe there's a standing meeting or something like that where you're focused using data like this to try and inform decisions. How do you kind of think that changing behavior process?
Yeah, well, I think it's really going to come from a lot, if not all, of the columns you mentioned. First of all, our policy is not to ignore alerts ever. Over time, we've seen other enterprises and businesses fall victim to attacks, and a lot of times when they look back, or once there are articles written about it that reach the public space, what we find is that there are alerts, or sometimes those entities had tooling that was actually telling them that something was happening in their environment. Those alerts went ignored. So we definitely try not to do that. Beyond that, take an alert like this where a manual action was taken. We strive to automate as many user actions on the DevOps side as possible, right? That it allows us to +1 changes to, it just gives us an assurance as to what's happening in our environment. Now, in the real world, as we know, sometimes administrators have to go in and make changes manually. When that happens and we get an alert, saying that so and so took X action, we can use the alerts we get from ThreatStack to establish patterns and go back to our dev teams, or our DevOps teams, and say, hey, we've noticed that you've had to do X, Y, and Z on a somewhat regular basis. Maybe that's an action that we should automate or put increased controls around, so that if an alert were to come through without our something we didn't have a forward knowledge of, that way we would have it next time. So the alerts definitely improve our process in a variety of ways, and they act as a check for when those processes may have gaps.
Great. All right. So switching down to the second alert here that would actually be from an example CloudTrail feed, where IDS engine saw that a security group or firewall was reconfigured to allow ingress from any IP address. And it's worth noting that this is actually an example initial alert that we observed in that customer's environment, where leading into Black Friday, they one of the initial steps that increased their attack surface area for that botnet to leverage was them accidentally exposing admin ports on those Redis nodes in that Kubernetes cluster out to the internet. So there's an indicative alert to that initial breach. So, a SOC analyst gets this type of an alert, and they're going to be looking in to see how is the change made. One example that we often like to give is if you're managing your environment through automation like CloudFormation, Terraform, and so on, and then suddenly we see Bob, who normally leverages Terraform, suddenly starts to come in and log into the console and start making changes directly. We'll see, did they use MFA to give higher confidence that it was actually them? Where did that request come from? So maybe it was a residential IP in SoCal, and we see that Bob's LinkedIn profile says that they're based in SoCal, so we have higher confidence. But we kind of take all of that session context, along with what ports were being opened, what assets are in that security group, they're now having that port exposed, and then go pull additional session context from those assets, right? So were there additional changes to CloudTrail? Was the port that was exposed, maybe SSH, port 22 on TCP? Maybe now we suddenly start to see those impacted assets in that security group start to have new SSH activity, right? So all of that we kind of bundle up and ship over to Michael and his team. And so, you were talking through kind of that direct end user access into the environment. But thinking about a configuration change that's, not leveraging automation, how do you track back those changes to the original user? And I know the tool helps with that, but kind of figuring out, back into your own identity now, or your own use of your own technology, how do you kind of link that all together and figure out who it was and why they were doing that activity?
Well, that could be make for a long answer, but
yeah.
Suffice to say is that our change management with respect to security group modification, our change management process is going to be pretty tight. The context that we would get from an alert like this, like seeing the username, whether or not MFA was used or not, would give us confidence in the alert itself, but it would really help us track down, what the hell happened, so like here, we would probably go directly to that user or manager as part of our triage process and figure out what went wrong. I mean, God forbid something actually went sideways and that user's account was compromised. But it would really, it would be situation dependent, and it would be informed in large part initially by these kinds of alerts. So I'm not sure if that completely answered your question, but suffice to say that there'd be an investigatory process where we, try to get down to brass tacks and figure out, what gave rise to this.
Yeah, no, and you covered a little bit on the previous alert too, but no, that's perfect. And I think the last question on this is, if you were to see either one of these types of events, maybe privilege escalation on a box that had that abnormal SSH after this, security group update, philosophically, maybe even just answering for yourself personally, not the whole security team over there. What's kind of your take? Do you like to take that potentially compromised or that confirmed compromised asset, EC2 terminate or burn it with fire just to remove the issue? Do you personally, prefer to isolate in the hopes of doing defer or pulling backups? Like, how do you personally like to think about that isolation container?
I think like you, like us, are responsible for your customers' data, and your stakeholders, and there's a lot of stakeholders in our businesses. So my first inclination is going to be to burn it with fire. We'd have the forensic data to support any investigation after the fact, but I definitely want to end problems as soon as they occur, and that's kind of my personal policy. We've got a variety of workflows surrounding incidents and incident response, but at the end of the day, you just want to kill it and figure out what went wrong and make adjustments so you can move forward.
Yeah, absolutely. All right, cool. So now that and it's just also worth mentioning, burning things with fire only gets easier in theory with Kubernetes, assuming that you have the automation there. But whether you're investing in automation on the container side or the EC2 side, at ThreatStack, we have not adopted containers at all, except for in some pieces of our build pipeline. We got all the kind of DevOps velocity benefits and the security benefits of just having that VM level isolation with EC2. So that was our preference, and we just leverage EC2 terminate instead of burning down a pod. But we don't always get to do this, but we love to kind of end a security webinar on a positive note. So Michael, kind of as we start to wrap up here, now that we've discussed what some of those bad days look like, can you go through kind of the positive outcomes and how you've been thinking about the whole experience holistically?
Yeah, sure thing. I mean, I think that from the beginning, we've wanted an effective partner to assist us on our side of the shared responsibility line. And ThreatStack has brought us a lot of benefits there. When we were searching for security tools, we needed something that would give us visibility across our deployment stack. We needed a tool that could give us, intrusion detection, file integrity management, monitoring, single platform visibility into the tools that AWS provides us. We really had to have that fundamentally in a demonstrable, continuously compliant way. And to that end, ThreatStack has grown with us. It's enhanced our security capabilities in cloud and subsequent containerized environments. And that solution mirrors not just our experience, but probably that of the industry as a whole. As you mentioned, over time, we've also leveraged your managed detection service. And there we've benefited from the insight and gained and learned from, we've benefited from the insight you've gained from customers across industries. And that's given us an additional check on our own processes. As mentioned here, when you work in the cloud, you take a responsibility for your piece of the puzzle, and using ThreatStack, using ThreatStack to do so is, a relationship we've been grateful for, and we've gotten the benefits to date.
Awesome. Well, I really appreciate that, Michael. And, to wrap up, as you've seen, audience, at ThreatStack, we help global enterprises like SailPoint securely leverage that business benefit of the cloud with proactive risk identification and real-time threat detection across different types of cloud workloads, whether it be containers, EC2 instances, serverless, applications you're building, anything like that. So please reach out to ThreatStack, or please reach out to us through threatstack.com for more information. But this time, it looks like we've got some time left over, and we'd love to move on to the Q&A portion of this webinar and answer any questions that have come up during or you might have now.
Thank you, gentlemen, for the presentation on what you guys have. We had a couple of new members joining us, a solution architect from AWS, Samir, to address any questions we have from the audience in regards to AWS. And of course, the members from ThreatStack and SailPoint to address any questions there. So either please ask your questions through the chat or and we'll address them accordingly. Okay, if there aren't any further questions, we definitely appreciate everyone who joined. And again, if you would like to seek more information, either please visit ThreatStack or AWS's website, and we could go forward from there. Thank you, everyone, and have a wonderful day.
Thank you.
Thank you.